Stay strong.
Stay safe.
Stay safe. Stay safe.
Stay safe.
Stay safe.
Stay safe, everyone.
Stay together.
Healthy.
Stay hydrated.
Stay
Test.
Stay fresh.
Get through this together. Stay strong, stay safe, stay at home. Stay at home, yeah. Stay at home.
くれぐれもお体をお大事に。
Assalamualaikum and a very good morning to everyone. I am Diana from IK Academy and I would like to welcome all of you to our webinar of the Learn with IK Live series organized by our iClub by IK community page in Facebook. Do join our community page and don't forget to invite other people so that everyone can gain something beneficial from it. Just go to the page and click join. As a friendly reminder, please register yourself through Eventbrite to make sure that you won't miss any notifications for our upcoming events, and as a record purposes that you have joined our webinar today. If you have any question to ask about this, just type in comment. Our crew will attend to your questions. And don't forget to type hashtag IK Academy. I would like to say thank you to all our returning audience because I saw some repeated client in the Eventbrite registration, and to those who are new and this is the first time that you heard about us. We are a technical training provider. At IK Academy, we train and we integrate knowledge technically. Neutrality is our priority. We are totally brand neutral with a strict focus on education. Our training programs cover power, maintenance, environment, building facilities, mechanical, electrical, project management, and more. We are committed to provide the best learning experience to everyone because we believe learning is a lifelong process. Before we proceed with our webinar, please like and share this live webinar with those who you think will be interested with our sharing today. You may click the share button and share directly to your page, or you may share around the link via WhatsApp, Telegram, or any medium that you may find, as long as it can reach to as many people as possible. And also, please type hashtag IK Academy in comment to show your support and also your presence today. So today, we will have a webinar with the title of Components/Technology Selection for Solar PV Projects. Our invited speaker, Mr. Channa Silva, will share his knowledge and experience with us. So let me read a bit about his profile. Yeah. Okay. Mr. Channa Silva is an international consultant in solar PV with over 10 years of progressive experience in strategic planning, engineering, project development, training, and project management for solar and renewable energy technologies. He holds a Master of Engineering Science in Solar and Renewable Energy from University of New South Wales, Australia, and a Master of Engineering Management from University of Technology in Sydney, Australia. He is also a certified expert in climate and renewable energy finance by the Frankfurt School of Management in Germany. Starting his career off as an electrical engineer in Sri Lanka in 2011, Mr. Channa focused on solar PV by working in Australia. In 2015, he took over the role of the head of projects and technical sales at a leading Sri Lankan solar PV firm. During his tenure, Channa overlooked the execution of over 30 megawatt plus of solar projects as a project manager in more than 50 geographical locations. In 2019, he co-founded N Solar Consultants, a Sri Lankan-based international consultancy firm where Channa leads as the Chief Technical Officer. N Solar Consultants provide all relevant services on solar PV technologies and conduct research on novel technologies such as storage, agri-PV, floating PV, and hybrid systems. As of date, he has provided his consultancy and feasibility study for over 400 megawatt plus of projects worldwide in countries such as Sri Lanka, Australia, Fiji, Bahrain, Oman, Bangladesh, and Maldives, and supervised over 50 megawatt plus solar PV installation. He has also worked with UNDP and as a consultant for ADB in carrying out project feasibility study. Further, Mr. Channa is a trainer under Solar Energy International, Colorado, USA, and conduct training and workshop in solar PV technology. Well, we are delightful to have Mr. Channa Silva all the way from Sri Lanka together with us today. So Mr. Channa, you can switch on your camera and also unmute your mic. Hello.
Hi,
Okay.
Channa.
Good morning. How are you?
I'm good. Thank you.
Yeah, so I think your time, because just now you mentioned it's around 7 something, right? 7:30, quite early.
Yeah.
So sorry to disturb you early in the morning to share about our topic today. So to everyone here, please say hello to Mr. Channa by typing in comment. And also don't forget to type hashtag IK Academy. So are you guys ready for the webinar? Because I am. And again, I would appreciate your help to like and share this live show to everyone that you can think of. Or probably you can share it in your community page in Facebook, LinkedIn, or anywhere else now so that they can join us together. And if you have any question throughout the webinar, please feel free to type your question in comment section anytime, and I will read your question at the end of the presentation. So I guess, Mr. Channa, you can share your slide now.
I will.
Yeah, you try.
Is it? You can
Yes, yes, I can see it. Okay, so enjoy everyone. I shall leave the screen to Mr. Channa. Bye. Anything you can call me, yeah?
do production. Okay, sure.
Okay. If let's say I miss out anything about your profile, just so you can add in.
Okay, okay, thanks.
Okay. Thank you.
Okay. Good morning, everyone, and I welcome you all for the presentation and the webinar on component and technology selections for solar PV projects. Myself, Channa Silva, I'm a solar consultant and trainer. So I'm going to start the webinar right now. And uh, 1 second. Okay. Okay. Today's discussion points is to identify main components in a solar PV project and its importance, to understand different inverter architectures and their pros and cons to the plant performances, and to evaluate solar PV products available for manufacturers for final design. So mainly we are going to discuss about PV modules, PV inverters, and some of these areas and some of these information about the mounting mechanisms. So when it comes to a solar project, the products, there are wide range of products, but the main products that we are going to discuss is PV module and PV inverter, and mounting mechanism is the main product. But other than that, there are a lot more to discuss. But in this webinar, in this short webinar, I'm not able to give all the information about each and every product. So probably we can discuss all this information in the upcoming training program, which under IK Academy, utility scale PV system design, and the other course on system design part one course as well. So let's start the webinar. So every project has its own journey, and solar project, so do the solar projects as well. So I mainly divide solar project journey into four categories, four stages. The first stage is the feasibility study. The second stage is the permitting, planning, and contracting stage. Third stage, EPC and project management. And the final stage is the asset management, which is the operation and maintenance. Under the feasibility study, if you required, we can divide it into two parts. Concept development stage, it means the pre-feasibility and the feasibility stage. Then the planning starts, all the planning work and the permitting requirements and the regulatory assessments, and also EPC finalization at the second stage of the second stage. And all the installation work start at the EPC and the project management. As I told, like asset management means the all the roles and the responsibilities of operation and maintenance, which to be done at the asset management stage. So the topic today we are going to discuss is about the component and technology selection, which is directly relevant to the feasibility stage. So at the feasibility stage only, we first do select the technology, and then we go ahead with components and brands, and finalize the brands and the components based on that. So that should relevant to the financing as well. So once you finalize the financing, you can select the relevant brands and the relevant products based on that. But before that, the relevant technology is to be decided. So let's start with the main topic of PV module selection. So how to select the right module. Before you select the right module, you should get the understanding of what are the features, what the technical specification for the right module, and what is the selection criteria for selecting a PV module. So for that, to get the understanding of the PV module, we should first look at the data sheet, because looking at the data sheet, we can basically identify the main features and the specification characteristics of each every product. So we'll take one by one all the features. The features, the specification perspective, we can divide it into several categories. So first I take the mechanical and general information. So under the mechanical and general information, so we can see dimensions, area, thickness, weight, and cell type, cell dimensions of each module. So these are very important. So today I'm going to discuss about a PV module technology is available, whether it's a crystalline or thin film or any other model. I'm just focusing on technicalities. I'm just focusing on the specification of a PV module and what are the things that you need to check over when you are selecting. One second. When you are selecting over, sorry, PV module. The second point is glazing. The most of the crystalline modules use low iron and high transparent tempered glass with anti-reflection coating. And so the low iron glass has high clarity, and tempered glass shattered into small fragments in case if it's broken. At the same time, backsheet also the most crystallines having plastic backing materials, and most common and popular materials for solar modules is the Tedlar backsheets, which is a polyvinyl fluoride film. So, and these days, most of the manufacturers have their own brands, but in the data sheet, they won't mention it. So, what is the material of the back sheets? If you really insist and if you really request, you can have the Titler back sheet and the specific back sheets, but the cost will be higher. So, I'm just wanted to highlight some of these specification in general category. So, what are the things that you need to look into? And same time, so all these, glass thickness and the backsheet material, if you change parallel to the changing from the benchmark product, so it'll impact on the pricing. So that you need to keep in your mind. And the another product is the which include in the PV modules is encapsulants EVA, and which is a glue laminate such as ethylene vinyl acetate. It used to seal, protect from the back and the front of the cells within the module glazing and back sheets. And one of the important one is the frames. Some crystalline modules are frameless, which it can be glass to glass, and most of the crystalline modules comes as uh, anodized aluminum frames. So in this picture, you can see that clearly anodized, cleared, anodized coated aluminum frames with white backsheet. And in this image, you can see that the dark backsheet with the black colored frames. So aesthetically looks good, but in general you can have like these type of crystalline modules. And when you request the special frames or the thickness and the color or any other let's say go ahead with the glass to glass or any other specific uh, specification change, so parallel to the changes, the cost will be changed probably by half cent or 1 cent from the module manufacturer. So in that case, so the first idea is to give you that when you're finalizing a PV module with a particular brand, you take the bill of material of the particular module and get the dimensions, get the weight, get the specification of frames and glass and the back sheets materials and everything. So you finalize the price based on that. So another set of general information is the connectors. So the module lead connector type is very important. All the days we discuss about the multi contact and it being joined by the different types of contactors, connectors. So that's important. So end of the day, connectors are see connectors is connected with the inverter, or the connecting with the parallel modules. So compatibility of the connectors is very important. So in that case, you have to think about the compatibility. So think about the brand or the type of connectors that is being used for the PV module. And same time, the junction box, normally we don't open junction box, but when it comes to the field service, yes, junction box can be open, and it can be replaced with bypass diodes, and the expert can do the necessary changes. So basically, as I told, like this information, these features to be checked as the general and the mechanical things. And probably, so as I said, like when you check about the mechanical and general specification from the datasheet, the length of the cable and the connector type has to be checked. If those things are changed, then parallel to that, the price will change. So that's why, so when you're finalizing a technology, so and by finalizing a component, so finalize the product specification first, then you can finalize the cost based on that. And the electrical information. So what are the electrical data that you need to check? So the first, at a first glance, that you can see the IV curve, which is generated at the standard test condition for every single module. And in the IV curve, it contains the 5 significant data points, which are, we can see that the maximum power point, as you all know, where that your module power shows, and maximum uh, PowerPoint current, we call it as IMP, is which is here, and maximum PowerPoint voltage, which is here to this, and the short circuit current and the open circuit voltage. So the standard test condition we have discussed in general, we give which is like 1,000 watt per square meter irradiance, and 25 degrees cell temperature, and the air mass of 1.5. So for those test conditions, we call it as the standard test condition, this IV curve plots for every single module. One of the things I need to highlight is, in real life, in the real condition, you won't get that lab conditions like 1,000 watt per square meter and the cell temperature. It's keep changing. So in that case, every instant, your IV curve changing for each module. So if you connected in series, your series string also IV curve for the particular string also keep changing. So in that case, in practical world, your maximum power point for every second, every instant, it's keep changing. So let's say if it is not 1,000, it's 900 watt per square meter, then your current comes down. Parallel to that, if cell temperature is increasing, as you all know, so when temperature is increasing, your voltage is coming down. It inversely proportionate. So we'll quickly go through these electrical points. The maximum power point is the knee point of the IV curve. So that point represents the maximum voltage and maximum power, maximum current, multiplication of maximum current and maximum voltage, and the power voltage represents the multiplication of both two. And VMP at the standard test condition under load, the highest operating voltage a panel can occur, and same time that has to be adjusted for the highest operating cell temperature. If the temperatures go beyond 25 degree, and you have to adjust it, that VMP operating your for the minimum voltage, minimum number of series modules is to be calculated based on the highest temperature. And VOC is when module is not connected to a load and there's no current flowing. So what's the voltage? So that the maximum possible voltage in a PV module. And if your ambient temperature and the cell temperature go below 25 degree, so you have to recalculate your VOC. That could be adjusted VOC, which could be higher than the module datasheet value. That will important for the system design perspective. And the maximum point, maximum power current is the standard condition, highest amperage the module can have. Simply, that's useful for the voltage drop calculations and the wire gauge for the PV circuit. And the short circuit current is the maximum possible current which module can produce. And simply this is relevant to overcurrent protection and the size of the conductor and the size of the DC equipments to be sized. And one of the other factors mentioned in the data sheet is the NOCT values. And so it means try to define every PV module manufacturer about the real life condition of 800 watt per square meter and the ambient temperature of 20 degree. Earlier case we've seen a cell temperature of 25 degree, but in this case they are trying to define its ambient temperature of 20 degree. But in that case, ambient temperature of 20 degree, if it's a working condition, your cell temperature could be in 40s or higher than 20. So wind speed of 1 meters per second. And so you have to do the calculation for the current and the voltage for these numbers. So what the PV module manufacturer is trying to show is when it comes to real world, so how your PV module is working. So, but from my perspective as a designer, PV system designer, NOCD values, you don't need to think too much. You just take the consideration value relevant to the place where the system you design. For example, let's say if you do a design for the Kuala Lumpur, Malaysia, so check the maximum temperature and check the lowest temperature, possible temperature for the location. And based on that, you have to do the relevant design. Just you can give up, giving up all the NOCT values which relevant for that particular modules mentioned in the datasheet. And the other parameters like the PV module power tolerance. So power tolerance is very important. It means that how much uh, the module can deviate from its standard condition power. So for example, these days you will, if you order a PV module, you will get extra 5 watt because every PV module is mentioned as power tolerance is 0 to plus 5 watt. Earlier days it's positive plus or minus 5% of power capacity is being defined for uh, as power tolerance. Let's say if it is plus or minus 5 watt for like a 300 watt, it means that if you order PV modules you will be getting 295 to 305 watt PV modules. So today's world, everything is competitive. You will always get the positive power tolerance. Let's say that if you order 500 watt PV modules, you will get like 60% from the 500, probably like another 20% from 502 watt, and another 20% from 504. So always you get the positive, and that will advantage or that will increase the current class, and that will also increase the energy output from the PV module because you're getting some extra amount of wattage from each uh, PV module. Module efficiency in the sense, so that's also one of the factors, especially with the area and its conversion efficiency. So the amount of solar PV, solar energy is converting to the usable electricity. Nowadays, you can see that the module and the cell efficiency range goes 21, 22% for the commercial. And 3 years back, 4 years back, the range was in the range of 80, 18%. And a couple of years back, maybe 5, 10 years range, probably it's 14 to 15, 16% of module efficiency. And the cell efficiency is slight higher than the PV module efficiency because in PV modules, you can find out some spaces in between cells. So it means that the cell efficiency is a bit higher than that. And so all these factors to be, especially the as efficiency factors to be checked, because when you're making design, especially if you're restricted with the area. The temperature coefficient also one of the factors. So you can think about the behavior of PV module. And we take the example of in this case we can see the temperature coefficient of power which is minus 0.35. It means every degree increase of your cell temperature reduce your power by percentage of 0.35. For example, let's say we consider the example of module temperature reaching 58 degrees. So 58 degrees, uh, that your temperature with the cell temperature, your standard test condition is 25 degree. So the temperature difference is 33. So that will impact on your coefficient, and 33 temperature difference multiplied by negative minus 0.35%, which is 11.55% of your original, power is reduced because of the cell temperature increase. Let's say that your PV module power capacity is 450. If you multiply this minus percentage, and you can see that when the PV module temperature is reaching to 58 degree, so you lose 51.98 voltage from the standard test condition power values. So when you're making decision, when you're selecting a PV modules, this is one of the important factors that you need to check. So higher the temperature coefficient, and you will lose much higher at the higher temperature. So if your ambient temperature at a much higher range, so then you have to think about power temperature coefficient of power. So when you are comparing PV modules one to another, so that's important factor. So this is a research exercise which we can see for monocrystalline and the multicrystalline and some other technology. So for different irradiance condition and the field irradiance with the lab condition and the field condition. So how this, temperature coefficient is changing. So I'm not going to explain too much on that. As I told you, like when you're making design, please check on each modules temperature coefficient. This matters because you can see there's 11% you are losing because of the temperature coefficient and temperature of the outside. So that's a huge. I think like as for my experience, if this from the dust or the soiling is is heavy, if it is not heavily impact on your performance, then this is the major part of the loss for a solar PV system. So in that case, better to go ahead with a lower number for temperature coefficient when you are selecting a PV module. And what are the other factors that you need to think over? The system voltage. For example, for residential PV systems, the maximum allowed voltage is 600 volts. And for the commercial purpose, you can see the 1000 volts limits are there. And the utility scales we can see today's world is 1500, 1500 volts. And when you are designing a 1000 or 1500 volt system, so your equipment, your PV module should be rated for 1500 or 1000 volts, because let's say if you do a 1500 volt system design and you're selecting 1000 volt PV module, so that means that your PV connectors and and PV connectors cables are rated for 1000. So in that case, that's not suitable for the 1500 volt system. So in that case, maximum system voltage has to be checked, and when you're making a right decision, and the maximum series fuse rating, and always protect your PV modules from the possible current can from the parallel strings. So that has to be checked, and the design loads, the weight that module can has been tested for without damage, and that has to be checked. And the maximum wind speed, for example, so you have to check about the maximum wind speed the PV module can handle without damage. What's that range? If you are installing solar PV system in a the category 4 or category 3 wind speed area, or the area which having a cyclones, so you just think about it. And the certification and qualifications is very important. First you need to check what are the local regulation, what are the requirement of local regulations. So based on that, you have to finalize whether the particular module, let's say if it is one of the cheapest module in the world, it won't provide the regulatory code requirements, then there's no point of buying it. So in that case, you have to first think over that. And the warranties. So when it comes to warranty, very simple. It's a normally these days every PV modules as the industry standard provides 10-year, 12-year product warranty and 25-year performance warranty. And some manufacturers we've seen that they have extended 25-year product warranty as well at extra cost, but it's not seen regularly. But 10 to 12 years is acceptable. And same time, if you can have like third party insurance backed by the manufacturer, So that is recommended, even though it's at the extra cost, probably at a half cents per watt, USD half cents per watt. Maybe they will, incur. So that's you to decide and how to negotiate it with those pricing. So when we select PV module, so we can use the multi-criterion decision-making process, the analytical, hierarchical process. There's a probabilistic, calculation can be done when you're making, this is a popular method for efficient decision making, and there are a couple of steps. So first, you need to, figure out what are the module types that you need to compare, and then you can do the main criteria, and parallel to the main criteria you can have sub criteria. For example, PV module, we can compare about the technology, electrical characteristic, mechanical characteristics, certification, environmental concerns, and the customer satisfaction. Each of these main criteria you can have like sub criteria. So you can, for example, let's say in this example, so I took it from the research paper. In this research, they have taken consideration for electrical characteristic, peak power, peak efficiency, power tolerance, fill factor, operating temperature, nominal operating cell temperature, temperature coefficient, and the maximum system voltage. So basically, we can say like almost all electrical characteristics is being considered. If you want to remove some of these factors like fill factor or any of these information, you just can avoid it. It's up to you to decide what are the things that you need to take to the consideration. And same time, as the steps two, we just take the consideration and give the portion of, to each category. Technology is 28% weighted for the calculations, and the electrical 25, the mechanical is 10%, and the certification is 10%. Customer satisfaction is another 25%, and environment is 5%. So let's say that if you want to change these numbers, let's say the certification is to 5%, that's, it's up to you to decide and change how you prioritize what exactly you require to be prioritized. So it's up to you to decide that. And then you just need to make a, quick comparison. I haven't mentioned the brands here, just want to be very independent and, mention those electrical technology and the customer satisfaction, environmental and certification, all the details, the specific details in the table. And then we can, give rating to that. For example, the product one, let's say if you're giving 3 points, and compared to that product two and product three, it's 2 1. So you can rate those for each subcategory, and once you've done that, you can multiply it from the probabilistic number, and you can take the addition of every single column and take the global priority number. So because that you are prioritizing the main criteria and the sub criteria, so you can take a decision. And if you want to consider this with cost, and so you can take the consideration. Probably cost can have like much, higher weighted number, probably like 30% for the cost and the technology for the 70%, likewise. So you can take the decision, based on that. Since that I don't have much time with this webinar, I just want to give you introduction. Probably I'm looking forward to take all this information in the advanced training program, which is going to happen probably within next month. And I would like to, have a much good case study on this. So I'm just keeping this slide and just want to give you a heads up about what are the, technologies and, techniques available when you're making decisions. And I'm having like a very quick efficiency comparison. So when you're making a decision of a PV module, and the efficiency is factored if it is a ground mounted project or roof mounted, if you are restricted with the area. So selecting a high efficient panel is very important. So if you, let's say if you have a target of higher number of PV modules or the power capacities, yes, you have to go for like a higher capacities. I just, got a, update from this website about like the panel capacities available. But nowadays, the manufacturers reach to 600 watt class and 660 watt class as well. The efficiency ranging would be this range 22, 23, that range. So you can have your own table when you're making decision. Maybe you can add the prices as well. So when the technology is new and the technology is, cutting edge, the prices will be definitely higher. And same time, if you are having like much higher capacities of a PV module, yes, of course you can save some amount of money from the balance of system as well, maybe from structures, labor, maintenance. So when you're making a decision, you have to have a cost benefit analysis, do a proper costing for each technology, and do the benefits as well, and weighted based on these cost benefit, you can take the decision on that. I'm not going to going too much into the cost benefit analysis for PV module or any of the technologies here, because with the time restriction, just want to give you a heads up on that. And our first discussion point on PV module technologies being over, and I'm quickly go through PV inverter technology. And selecting a right inverter is very critical, because inverter is the brain of the system, and inverter is the equipment converts DC current to alternative current, and same time it controls the quality of the power output to be delivered to the grid. So what are the main features, and what are the main functions, and what are the main components and the functionalities included in a PV inverter? First one, and the main one, is the maximum power point tracking. Maximum power point tracking, just a second. Maximum power point tracking is, to maximize the energy available from from the photovoltaic generator during its operation, and same time the bulk capacitors is used to prevent the ripple current reaching to the DC source, and same time DC to AC inverter, which is converts DC to AC, and the filters is being used to provide the quality of the power output to be delivered to the grid. And same time those filters to be filters allows the generators, generations of sinusoidal voltage with a lower harmonic distortion. Inverter is a current generating source, it's not a voltage generating source. And what it does is it sends the grid voltage and the frequency, and it pushes current to the grid with having a potential difference. So switch on the inverter, we need to comply with three conditions. One is the AC voltage, AC frequency, and the DC voltage. Once it's done, it's try to identify the voltage waveform and push the current from the inverter itself. And there are three type of inverters. The first one is the central inverters. So I'm quickly go through these information. The central inverters is used for the large scale applications, and few hundreds of kilowatts and few megawatts is to be installed. And very we've seen that for a large scale application, the utility scale application, central inverters being used. Hundreds of strings is being connected to combiner boxes. The parallel combiner boxes are connected to another parallel recombiners, and then it connected to inverters. So simply we can say that the lower capital cost and reduced number of inverters is the main advantage. And when it comes to disadvantages of the central inverters, it's too bulky. And same time, since that the most of the cases we've seen that the central inverters does have uh, uh, one single MPPT, uh, one single MPPT. So in that case, there could be a mismatch losses, and same time those mismatch losses impact on the lifespan of the PV inverter. So we quickly take one after the other of the inverter technologies, which is the other one is the string inverter, most popular inverter in the solar PV world, and it has one or more several maximum power point tracking as the input. It try to track the maximum voltage and the maximum current of each string. So each string provides the IV curve for for the operations. And advantage, we've discussed that the robust and mature technology, the cheapest and the most conventional option and simpler to installation, the module installation. And cons, the disadvantage like lower performance, again the partial shading, and the low performance, again the multiple orientation. If you have multiple orientation, multiple tilt, and the shading impact, you have to have uh, several numbers of MPPT trackers to be track, and to get the maximum power. And future expansion also, you have to have inverters for that. And let's say if you have a one failure module in a single string, that will impact on the performance of the particular string. And the other type of inverter product is modular power electronics. Modular power electronics we can categorize into two parts, which is the optimizer technology and the microinverter technology. Optimizer technology does is like it's having PV optimizers for every panels, and all these optimizers are seriously connected to another string inverter. So one of the main advantages is like you can have like module level controllability. It has the module level maximum power point tracking and DC to DC conversion. And same time, these optimizers does have uh, the buck boost converters to change the voltage and the current. And most of the cases we've seen that the inverter having a DC string fixed voltage and DC to AC conversion done at the end of the inverter point. So most popular optimizer technology provide is Solar Edge. It's one of the popular so the optimizer inverter and technology brand. And in US there's a requirement of rapid shutdown as per the NEC 2017 requirement. And so this product provides that. If you use a string inverter, so you have to have additional components for that. And the disadvantage are like expensive for sure. And the microinverters is the micro scale, the smaller inverter to every module. uh, so DC to AC conversion at the roof end as well. And the advantage is like you can the shading or any other partial shading or anything, so that can be avoided. So that may impact on the particular module only. If you're using the optimizer technology, the same as that, it can control the module level same as the micro inverters. And you can monitor the system module level as well. And this, but the cost is higher. The compatibility with the batteries also some with lesser. This is a quick comparison of all the technology. The very simply that I want to highlight is like efficiency wise. So, the lowest efficiency category is like compared to all four central inverter, but nowadays the very efficient central inverters so available. And same time the disadvantages are we just discussed. Chance of failure, central inverters are low and the micro inverters are a bit higher. That's why that is you know uh, maintenance wise that's pretty difficult. But if you're messed with, especially with the modular power electronics, then definitely that will be a disaster. I've seen projects where that there are failure rates is quite high. But if you install it properly, if you do the installation well as per the guideline and the instruction of the OEM, so then that is a superb technology. So simply what I want to mention is, for a utility scale or a large commercial, you can use any of these technologies. It matters with the pricing. For example, let's say it's a central inverter price range of like 2 cents, 3 cents per watt, and the capacities range from 125 kilowatts to 300 megawatt inverters are available. But string inverters, the price range is 4 cents to 6 cents per watt USD cents. And nowadays it's lots and lots of application of utility scales from the string inverter technologies, because string inverters capacities ranging from 2 kilowatts to 250 kilowatts inverters are available in the market. And the micro inverters mostly for residential and the medium scale. But even though if you use for a large scale application, that also if you can justify the cost. So end of the day, you have to do the cost benefit analysis, as I told, and do the financial. And same time, if the investor is willing to pay for the extra amount and for the extra benefits, because of the you can have the much higher transparency, so then you can do that. And those factors to be considered when you're making decision on the technology. The factors is look for the project capacity. So what's the capacity that you should be you're looking for? So based on that, you can select the inverters and the performance and the MPPT voltage range. So if the inverter does have higher range, so you can go ahead with uh, you have the flexibility to change the string size as well. Single phase or three phase incentive scheme. So based on your application, you have to check the inverter capacities. Module technology. Some inverters, especially with the modular power electronics, is checked for the compatibility with the PV module technology program. For example, I've seen that the some optimizers and some micro inverters check for the cell type, cell number of cells for the 60 cells, 72 cells, or high number of cells. And the regulation. The transform inverter must be used in the galvanic isolation is required for the DC to AC side of the inverter. And the power quality compliance, these things is very much very important when you make a decision on. You have to first check the regulatory requirements when you make a decision on the inverter. And the product reliability, low downtime, maintenance, and the repair cost. And also you have to check the record of the particular products and the mismatch. So if you have a lot of mismatches, as I told, if it's a roof mounted, you have like different orientation, tilt angle, then you have to have maximum power point tracking. Otherwise, you have to go ahead with the MLP. And the maintainability and the serviceability. So that's one of the reliable factors to be considered. Wherever you stay, the support level from the manufacturer is very important, or else a regional support. So that's important. And the system availability, the modularity. So we've discussed these points, and the shading conditions. So you can have like multiple MPPT tracker, inverter location, that could be outdoor, indoor, or the more performance monitoring. So every single inverter brand provide plant monitoring, that could be string level or the inverter level. So that has to be comply with the requirement of yours. So when you're selecting and same time, the cost will be in line with that. So this is a data sheet I'm just keeping on that. And the AC output, what's the maximum power output that inverter can supply to the load. And peak power output, some of the inverters we've seen that it provide the surge power for the maximum power from the inverter for a short period of time. AC voltage is important. So we've seen that there are different inverters provide odd voltages as well. For example, some inverters provide, let's say that your three-phase voltage is 400 volts. We have seen some inverters provide 480 or 690 or 800 volt system. So you just need to check the frequency and the AC voltage. And the peak efficiency, there are two different type of efficiencies to be considered: the peak efficiency and the weighted efficiency. When you are making a decision, just check the weighted efficiency. Peak efficiency is the efficiency which inverter provides, uh, the inverter manufacturer provides. It's the maximum efficiency that the inverter can work. So but when you are making a decision based on comparison of different type of brands together, then you can take the consideration of the weighted efficiency from the datasheet. The maximum input current, maximum output current, starting voltage. Starting voltage means like where your inverter wakes up. So that matters with the minimum number of modules in a series string. THD, so we quickly have the look on that. And IP rating with the outdoor, it's indoor, and AC to DC disconnect and the accessories which are available, disconnected switches, DC AC SPD is available, the ground for protection. So these are additions. So we can check over that. It's a data sheet and some compliance standard I'm quickly go through. And one of the other factors is DC to AC ratio. When you are making a design, So you need to check that what is the oversizing capacity of the inverter is. Since that after the inverter to the grid side, all the infrastructure is fixed, if you can add more and more DC panels, so you can have additional yield generation. If you are going ahead with far ahead the much higher oversizing, it start power clipping. For those who know and those who don't know about power clipping is like when you are exceeding the amount of DC capacity, it start losing power during the peak time of the day. So you have to get the balance between power clipping and the additional amount of generation. So again, the cost benefit analysis come into the scene. So what is the DC to AC ratio? In general, as a thumb rule, we you use 25% to 30% as the optimum DC to AC ratio. But when it comes to utility scale, we can consider 40-50%. But your inverter should allow uh, that percentage of DC to AC ratio. So think, check with the OEM, check with the manufacturer, check with the data sheet, what's the percentage of oversizing and how it get benefited, and what the amount of power is being lost during the peak hours, and what the amount of additional gain during off peak hours, as well as the other part of the year. So in that case, think over it, and the cost benefit is important. Probably I'm looking forward to continue with a these cost benefit analysis in the training program, because I'm having very limited time with this webinar. So I'm just want to highlight these topics and give a heads up on what exactly is to be checked. And the mounting mechanisms is important. Whether it's a fixed tail structure or the solar tracking, again you have to think over the what is the cost and what is the benefit over going for a tracking. There are three types of tracking: manual tracking, somebody come physically come and adjust panels in the different times of the day; and the passive tracking. Active tracking is with the motor or the hydraulic cylinders and change the positions, and active trackers is being used in the practical world. And there are two type of active tracking: single axis tracker, simply it gives extra amount 15 to 20%, and the dual axis tracker, very small application is recommended, but we've seen that there are large scale application. But the countries like Malaysia, which close to the equinox, and it's probably single axis tracker get the maximum benefit. And an advantage is simply you giving the maximum amount of energy from the uh, and when it comes to disadvantages, probably we can take the consideration very expensive, high maintenance cost, and site preparation, and there are a lot more to plan. So there's a I'm just so a small case study on that, how this this is a single bell curve for normal fixed tilt, and if it is a tracking involved, you can see that so additional amount of gain. So simply the long term revenue wise, the tracking gives much higher revenue. But when it comes to the financial, I've seen most financials resist for these trackers because the capital cost is higher. Maybe it's 15 to 20%. So that will reduce the project IRR. So there are a lot more to discuss in future upcoming training program, and just I'm keeping those things. I just wanted to highlight these points only. And the ground structure is also the same, and the fixed tilt, the based on the ground condition as per the geotech survey. We can discuss on what type of the ground structures to be screw type, precast blocks, or the pile driven. And when it comes to roof mounted, we can have like three different type of integrated PV system: the partial integrated or the non-integrated systems. The finally I want to highlight that whether it's a mounting mechanism, you just need to do that basic cost to be done and line up all the advantages. That's how you have to select. Probably you can do probabilistic, or like simply the method that we followed for the PV module. Likewise, you have to end of the day happy with the finances. So based on the advantages, the technology can be selected. So In this webinar, I just wanted to highlight all these topics. What are the things that we need to think over, probably the execution ways and the case studies I'm looking forward to take from upcoming the training sessions. Unfortunately, I don't have much time right now to go much detail on those. Probably if with the next webinar or next upcoming trainings, I'm looking forward to take this information. Thank you. Just let me know if you have any questions. I think I took almost 55 minutes uh, of the training and the webinar. So if you have any questions, Diana.
Yes, thank you, Mr. Channa, for the sharing. And we hope that you all learned something just now. Probably you
Yeah.
can stop share your screen first. So to everyone here, if you have any question to ask, please type your question in comment because I saw a few questions already coming in. And as for the rest of you, if you don't have any question, you just type hashtag IK Academy to show your support and also appreciation to Mr. Channa Silva today. So before we proceed with the question, Mr. Jana, can you please stop share first? We wanted to share something.
Okay, sure.
Yep. Yeah. Okay. So before we proceed with the question and to give some time for everyone to write their question, if there is any, I would like to highlight our upcoming trainings that you might be interested in as shown in the screen. Please scan the barcode shown and click on the link shared in the comment section to get more details. Okay, so let's continue with the question. We have quite a few. So probably I go with the first question that we received from Eventbrite registration. So the first question is that what in Malaysia, are they the solar installer company use forecast data from weather before install the PV system? Because Malaysia already, I mean, like sunny and receive solar energy from 7 a.m. until 7 p.m. So that forecasting solar energy needed in climate area like Malaysia, is it needed?
Basically yes. Whether considering whether consideration of weather data is important. So the I know the sunlight is available from 7 a.m. to 7 p.m. But our consideration is concentrated the irradiance, which for 1,000 watt per square meter.
Mhm.
That amount of hours is not 12 hours, probably till around 6 hours.
Correct.
And I'm looking forward to explain these things. Probably I'm just not marketing about the training program, but these things are included. So this will be a lengthy. So for in a nutshell, just want to highlight that. So if you are into design, yes, you have to consider the weather data for specific location for sure.
Okay, thank you for that explanation. Then probably I'll read a question from Facebook. This one from Mr. Jasrul Jamani. So he mentioned Panasonic is among the highest efficient panel in 2022, but why it is not among the top 10 popular PV module?
Uh, that uh, I'm not sure specifically what exactly the reason. So I'll give you a quick, answer for this one. So when it comes to the module PV module ranking, the Bloomberg New Energy Finance has their own list based on the volume each manufacturer is exporting. So that's how they listed, and same time they check the bankability records as well as the financial stability. So yes, Panasonic, LG, they have the highest PV, efficiency modules. I've used Panasonic as well, but I don't know why. What's the reason if it is not listed? I don't know. I'm not
Okay.
going to highlight any of these brands here. Yeah.
Okay, thank you for the answer. I hope Mr. Channa answer your question, yeah, Mr. Jasrul. Okay, so I back to question from Eventbrite. What are the different panels used specifically for homes?
There's no specifically panels for homes. In general, all are commercial products. Even it's a 500 watt or 600 watt or 300 watt for homes also can be used. But end of the day, you just need to think over these mechanical factors like weight and the size of the PV module. If it is relevant to your home, you can have it. For example, let's say you want 3 kilowatt system. If you use 300 watt PV modules, you require 10 number of modules. If you use 500, you only require 6 numbers. There's no thumb rule for that. Your which are available and the lowest cost with the highest technology, good for any application.
Okay, thank you for the answer. And then I'm back to question from Facebook from Encik Muhammad Firdaus Johari. With new technologies and innovation being done, are there new materials can be used for solar panels?
Yes, there are different techniques is being adapted by every manufacturer. The solar industry is so dynamic and it's keep changing. So again, I'm not going to give you a lengthy answer for this one. So yes, it's different materials, different semiconductor materials also being considered, and it's happening every day. And they in lab level they achieve like the in commercial level it's only like 20 to 23% efficiency is being achieved, but in laboratory level it's 40% plus efficiency is being achieved with a different material. It's continuously changing and it's keep adding. That's simply yeah.
Okay, Ken, thank you. Hope Mr. Channa answer your question, yang Encik Firdaus. You can ask more if let's say we still have time. Okay, so next is why power factor fluctuating during solar PV on peak?
Sorry, can you repeat the question again?
Why power factor fluctuating during solar PV on peak? I think during peak time lah, I think so.
Okay. It's not power factor fluctuation. It's a power is
Power.
fluctuate.
Okay.
So so solar is so dynamic when it comes to operation. Let's say for cloud cover, the sun part, so then keep changing from 100% to even 10% the generation. That can be happen. So that's the one of the I'm not saying it's a disadvantage. It's like a bottleneck of solar. So you to have like a smooth power, maybe you can integrate storage, battery storage for that, or else from the perspective of a country or the national the control system, you can have distributed solar plants everywhere. Let's say if one single place, if you have a 500 megawatt, if your grid capacity is not that too big, in a sudden change of a variation of power, that may impact on the grid. So in such a case, to have like a distributed power sources, that's one of the way. And or else you have to have like storage to have like smooth power. So but it's changing, it's fluctuating, it's very highly because of the environmental changes.
Okay, cost of environment. Okay, this one question from Encik Muhammad Sharul Izwan from Facebook. Actually, he got 3 questions he asking. So I read the first one. This one is okay. Can you explain more details on the MPPT?
Okay. Simply, MPPT is like MPPT is a technique or the algorithm which, from the inverter perspective, to identify for a given point of time, what is the maximum power point is. For example, let's say, so we considered solar irradiance under the standard condition is having like 1000 watt per square meter, and the cell temperature is 25 degree. But in real life, you won't get those two. So it keeps changing in every second. So inverter tries to identify its maximum power point and then get the maximum power for that string or the entire solar system and converts DC to AC. That's what simply MPPT function, the algorithm works. That's how it works. Basically, it's trying to identify and converts that maximum from every second, every instant.
Okay, thank you. Then his next question is for LSS, which inverter is the best solution, centralized or string inverter?
I'm not get what exactly the
Yeah.
L is, but
Yes.
that's fine.
Probably
Maybe
Mr. Sharo, you can type in comment. And his next question is if the inverter has MLPE, does
yeah,
it needs MPPT as well?
yeah. So I'll go ahead. Well,
Yes.
let's take the first one. So whether it's the small scale, medium scale, or a large scale utility. So as I told, like central inverter or the string inverters, both are using everybody. End of the day, the cost has to be justified as well as you have to consider the benefits as well. For example, you can buy out central inverters half of the cost from the string inverter. But another factors to be considered, the balance of system, for example, cost for the cables, cost for the handling, cost for the labor and the project management. So end of the day, you have to have a much comprehensive cost using central inverters, and the string inverter has to be done. And same time, compare the benefits. So once you can do all this, you can see the financial numbers and take a decision based on that. So in the world, there are applications from utility scale from the central inverters as well as from the string inverters. Both technology are popular. So when it comes to your question from the MLP, modular power electronics, modular power electronics always control its MPPT function at the module level itself. And same time, adding to your first question, you can use the modular power electronic application for the utility and the large scale applications as well. Same time, as I told, that's depend on your how much your investor is willing to pay. But I've seen in the world there are many projects with module level power electronics also being used for the utility scale, maybe like 1 megawatt, 2 megawatt, 5 megawatt scale, not for like much higher, bigger capacities like 100 megawatts, but there are people use MLPE for large scale applications as well. It's again depend on the how much you're willing to pay, what's the additional benefits that you're looking for, what's the transparency levels that you're looking for.
Okay. So Mr. Shahrul didn't say anything, only Mr. Firdaus just now say thank you to you for answering his question. Okay,
Okay,
so I have one, maybe I just read one last question if
no
there
problem.
is not any other question from Facebook. Okay, so when to do the component or technology selection, which stage of the project?
Yeah, that's important one, I guess.
Yes.
So basically, like, so we have categorized a solar project into four or five. For example, let's say it's a concept development, pre-feasibility, or the feasibility. Technology has to be selected at the concept development or the pre-feasibility stage. But once you have finalized the technology, whether it's a central inverter or the string inverter or these type of modules and these type of uh, the mechanical mechanism for structural insulation method. So once you've done that, you have to finalize your fundings, your financial acquisition. So once it's done, before start the EPC stage, before start the project management stage, you have to finalize the component brands. But I've seen in the world there are people finalize the PV module and the inverter first, and they start the project, and middle of the way they are finalizing others components. That cannot be done. Every single nut and bolt is very important. Even a connector can delay your project for months. So
Right.
in that case, you should definitely finalize at the feasibility stage. That's the most advisable way. Once you have finalized, the small deviation can be accepted. But I must say, looking at next 2 quarters, next 4 quarters, when you do the procurement, when it comes to especially with the module prices are keep changing with the global material pricing, global demand. Looking at all these factors, you can finalize PV module, and same time availability of the service and other factors, other products can be locally or globally purchased. So I always recommend to finalize everything at the feasibility stage. It means before the EPC and the project management stage.
Okay, thank you for the answer. So I guess if there is no more other question for the audience, I think we have come to our session today. So any last advice or messages that you wanted to tell the audience, Mr. Channa?
Yeah. So for today's webinar, I took because our focus is the system design course and the advanced course for the utility scale.
Okay.
I took this topic, components and technology selection, for my perspective, with my experience over last couple of years. This is one of the important stage. That's why I given you an introduction about how to what are the specifications that you need to check. So in that case, feasibility, most of the people is avoiding before you do a project every day. I know maybe most of you are engaging with projects every day, but every project has to be a proper plan, and that proper plan should be comes with a proper component and the technology selection, because the solar industry is so dynamic, it's keep changing every day. So you have to be updated every day, every time with the product line. So that's my key advice: always look at the technology first and then go ahead with the component. And
Okay.
component in the sense like the brands.
Yes. Okay. Thank you. Thank you, Mr. Channa, for your sharing today. I believe all of us here have gained lots of knowledge from you. So like he mentioned just now, if you interested to learn more from him, we have scheduled a session of training about, we have two topics. Yeah. One is solar PV system with design engineering and financial analysis. This one is next week actually. And another session about utility scale solar PV plant design engineering. This one on September 13 and 14 of September 2022. Please fill up the form via link that IK Crew shared in comments to get more details about this training. And we might have some special discount if you are really interested to join his training. So thanks again, Mr. Channa. And to all of you here, please leave some comments in Facebook, LinkedIn, and YouTube. And a thank you note to our guest speaker today. At least we know that we share something beneficial to you. And also don't forget to type hashtag IK Academy. Please like and follow our page in Facebook, LinkedIn, Instagram, and also join our FB community page, iClub by IK, to get latest news for our upcoming IK Live webinar series and also other content sharing. Do check our page for more details. Last but not least, please check your email for thank you email via Eventbrite to get the link or barcode to retrieve your e-certificate. And don't forget to claim it within 3 days. Well, I hope I can see you again. Thanks from me, Diana from IK Academy. Bye, everyone. Thank you, Mr. Channa. See you in other webinar. Bye-bye.
Hi everyone.
Hi everyone.
Hi everybody. Hi guys.
Stay strong.
Stay safe.
Stay safe.
Stay safe everyone.
Stay together.
Stay hydrated. Stay strong, stay safe, stay at home. Stay at home, yeah.
Stay home.
くれぐれもお体をお大事に。